screen, you should see the question you just asked me about, number 1, and then G. I actually say it this way, G bubble F, but it's really, it's the composition of functions.
Okay.
And what that means, maybe none of this is clear yet, but it means G parentheses F parentheses X.
Okay.
So there you have a function f of x right here, 3x plus 7, and wherever you see an x in g of x, because that's the outside, this is the outside function, this is the inside function, you take this 3x plus 7 and put it into this minus 4x squared. So it's minus 4 parentheses 3x plus 7 squared, like that. Is that okay? Is that clear?
Yeah.
And then from here you would simplify. So it would be negative 4, 9x squared. You multiply these, that's 21x, double it, 42x plus 49. And then you could distribute in this minus 4 to each of these as needed. Usually they want you to simplify this. It's up to the instructor whether that's needed or not.
I don't think she wants us to simplify.
Yeah, usually okay. Okay. Given f of x. Okay, so let's look at number 2.
Yes.
That's okay.
Yeah, that's perfect.
I assume you want us to just go through all of these.
Yes.
And it's great that you had this ready in advance, because it makes it so much easier for us to go through it. So they're telling you that they're giving you the function of f of x, and they want you to sketch the graph of absolute value of f of x. So that's absolute value. And essentially, if it's positive, it stays positive. If it's negative, it becomes positive. So for example, like there's some breakpoints here in the graph, and I'll just label them here. Wherever it hits the x-axis, those are sort of transition points. So let me use a different color here. Let me use blue. So this right here, it's going to come up on this side. Okay, because if it's negative, it becomes positive. That's pretty straightforward. The part here is already positive, so it just stays. This is already positive, so it stays. But this stuff down here, you flip it. You basically reflect over the x-axis. So this comes up, something like that. This part stays the same because it's already positive. This stays the same because it's positive, but this right here would come the other way. It would shoot up to, looks like it's like 4.5 there. Look, shoot something like that. So everything in blue, this is in blue, is what you're looking for there.
Okay.
And if there's ever, if anything is not clear, just ask me to repeat or go again, or just say I didn't get it. It kind of has to be all verbal, because I don't have any way to read your body language in this format.
Yeah.
All right, so write a piecewise equation for the graph here. Is this all kind of review? I mean, did you see this last year?
Part of it is kind of review, but for number 3, we haven't gone over it, but we ran out of time in class today, so I think she might go over that one on Thursday when I have her next.
All right, got it. So when I look at the graph here, I break it up into 3 windows, basically, where there's this thing on the left, this thing in the middle, and then this thing on the right. And then we just have to come up with equations for each of them. So for number 1 here, this is a line, and it has a slope, just like all the other lines. I guess your teacher crossed out what it was, but you could, for example, go from here to this point here and figure out, well, what's the rise over the run on that? You go up 1 and over 1. So it's y equals 1x plus, what's the b value? It's 2.
Yeah.
So you try to write, you're a pre-calculus student, you like, there's this expectation that you can write the equation of a line relatively quickly from a graph. Okay. So now in the middle part there, in the middle part in region 2, what is the equation of a horizontal line? Do you remember that?
Isn't it just y equals 2?
Exactly. And then in region 3, this one's a little bit harder. You can figure out the slope again. It's not great the way this is done, but like that point there is nice, and that point. So it goes down 1 over 1. So it's negative 1x. And then to get the b value, you could kind of project this here to be 3, like that.
Yeah.
So your function, your f of x, it's almost complete. It's x plus 2, and then minus x plus 3. The last part is the regions over here. So this is like the I don't know, these are the equations, and then over here is the domain that it works in. So like this one on the left is good for any value less than or equal to 0. Because right there it's a solid point. You see that solid there? This 2 goes from 0 to what value here? 1. It works in that region. So we're just giving, like, these are just the x values that we're writing now. And then the last one is good for x greater than or equal to 1. Now there's a slight problem here. I don't think your instructor intended these to be solid at each point. You can't have them defined at like both places. So we'll just choose, we'll say that the first one's good for less than or equal to 0. This one's good from 0 to 1, and this one's good for greater than 1. So we'll just undo that. And that takes that art, takes into consideration that. So this is your final answer down here. That's what your instructor is looking for. Can you break it up into 3 pieces? And see if you can write the equation. Is that clear?
Yeah, that makes sense.
Okay. I think number 4 is maybe more likely what you'd see on an exam if they had to choose one of them. They give you the function and then they ask you to graph it. And this is normally where you start. You start with, hey, here's the function, and then come over here to the right and graph this for me. So we're gonna focus on this top one here. Okay, and I suggest a table. So your x value goes on the left here, and the biggest x value it can be is 3, and then 2, and then 1, and I'm not sure how many. But the other thing I make a note of here is that this is an open circle. It's an open circle because of that symbol there. That symbol there means it's going to be an open circle on the graph. And then we figure out, well, what's 3x minus 2? So 3 times 3 minus 2 is 7. 3 times 2, I'm sorry, minus 2. So that's, I wrote the wrong number here. No, I'm sorry, that is correct. 3 times 2 is 6, minus 2 is 4. And then that's 1. So the first point, 3, 7, that's an open circle. Then the next point is 2, 4. We can fill that in. 1, 1. Now this is the part that most students often mess up, is you have to start from 3 and like go backwards. Like you have to connect this direction. It would be wrong to like go up this way because there's a break here. There's a window for less than 3. Is that okay?
Yeah, that's perfect.
All right, so now 4, we can make a table, and I will. It's the same value though. So this goes from 3, 4, 5, and 6, 3 all the way up to 6. But here, this is a closed circle, and at 6, it's an open one. So that symbol means it's closed. That one means it's open. The y value is always 4. So it's 4, 4, 4, 4. You already know that that's a horizontal line there. So I go to 3, 4, put in a solid dot, 4, 4, 5, 4, and then 6, 4 is an open one. And I just connect it in here. Is that all right?
Yeah. That one makes the most sense.
That makes sense. Okay. This last one would make the most sense without this fraction here. I'll try to talk myself around that a little bit here. So you might think to go 6, 7, 8, and so on. And the problem is like these numbers don't work well with that fraction, but I guess we kind of have to deal with it. You'd want to pick multiples of the bottom number there to do this. Your instructor is kind of giving you a more advanced question here. You know, I don't know what to to say, but that's the case here. So like at 8, you're putting, let me just come down here and give us a little more room. Like at 8, this will make a lot of sense. -3/4 times 8 plus 5. This works out really nicely because 3 times 8 is 24, divided by 4 is 6, negative. This becomes -1. It becomes a nice number. But when we do it at like 6, the problem is it's -3/4 times 6 plus 5. That's -18/4 plus 5. Well, that's -9/2 plus 5. So it ends up being, you know, that's -4.5. This becomes -0.5 when you go through it. So the idea is you're making a table of values. Unfortunately, this last one isn't very nice. Yeah. This is a closed circle because of that symbol there. And that's kind of right there. And then the 8, it goes down to 1. So it looks something like that. I'm just sensing this wasn't super clear.
The last one, I think that should be fine, but usually she doesn't really give us fractions with these, but
yes. Like if it was just -3x plus 5, you just write out a few values and you need enough to be able to make the graph here. And with a line, you need 2 points. So, you know, you don't need 3 values. You can get away with 2. You can get away with 2. Some instructors really emphasize like the beginning and the end point when they do this. We need to do more examples, I guess, to really like hash this out and get it down. But I just have a sense this maybe wasn't super clear. But let's move to 5 and then see, you know, where you're at when we get through all this. See if we want to go back and do more.
I think 5 is like the most confusing one because she didn't really like go over like the increasing and like the decreasing.
Yeah, got it. So you're in pre-calculus. Pre-calculus leads to calculus. Maybe you'll take it, maybe you won't. But these increasing, decreasing are calculus concepts, and they're trying to like introduce them now. So, all right, domain. Domain is you think of your domain as your x values. Okay, you're like, well, is there any like breaks? And you might say, well, isn't there a break here, Matthew, from this one to this one? This is a vertical break. We're talking about a like a horizontal break. And these don't, like, even though there's an open circle here, you jump. This is called a jump to get up to here. You're still just drawing it without picking up your pencil. So you might have heard that in class. Like, can you draw it without lifting up your pencil? Maybe not.
Yeah.
Okay. So the domain here is -infinity to infinity, because this goes to the left forever, this one right here. And when you come this way, even though when you get here, it's defined up here. So it's okay. And then it comes down and then you keep going out to the right forever. The range is the y values. And you're looking for vertical jumps now. So this vertical jump does matter. So like the y values, they let's see here, 1, 2, 3. So that looks like -3. The y values go all the way down to -infinity. This goes down to -infinity, and they come all the way up to -3. So -infinity to -3. Neither of those are included though when you're using interval notation. Is that something that you're familiar with?
No, I'm not.
Not okay. All right. Maybe we'll do another example of this right away. So now you might think, well, what about this up here? You have to look at it kind of as like what's the squeeze between them? Like what are the values? See how the y values are in between here?
Yep.
They're squeezed in. What's the smallest y value?
It was kind of blurry. I think
Looks
it
like
was
it's
3.
3, and maybe this goes up to 12.
Yeah, probably.
So it becomes everything from 3 to 12. So that's 3 comma 12. Now, does it include 3? It does. See how that value is included? And same thing with this one. So we use brackets for included values.
So then when it's not included, you use the parentheses.
That's right. So see how there's like an open bubble there?
Mm-hmm.
That's not included. This is a very advanced one. Like this is where like imagine you started out and you're like, okay, like what do I understand? Like this question is way up here at level 4, and maybe you're comfortable here at level 1 or 2, and you know, we got to get you to level 4, I guess, for this exam. Okay, let's talk about these last 3, and maybe we'll do another example right now. Constant's the easiest one to talk about. Constant means it's going to the right or horizontal, basically. So where is this graph completely horizontal?
I think it starts at. I cannot see, but
It's about 2-ish, right in there. And how far to the right does it go?
It goes. It looks like
Forever.
infinity.
Yes. So you always use parentheses for these increasing and decreasing. You always use parentheses. You don't have to use brackets for these. Okay, so now increasing means it's going up and to the right. That's what increasing means. So like this right here is increasing because it's going up and to the right. So you might even want to write those words down, up and to the right. So it's going up and to the right, and you're looking at x values. This goes to negative infinity. And then the x value here is -3. When you jump up here, this is not increasing. It's not going up and to the right, but from here it is. Here it's going up and to the right. So what's the window of this?
Would it be 3 up to?
It's the x values. So these are always the x values.
So 0 to 2.
Yes. Okay, and then decreasing is when you're going down and to the right. So the only place you're decreasing is in this state. You can think of like if you were on a sled or if you were sliding down, you know, would you slide down or somehow slide up, which is really hard to imagine. But here you're sliding down, that's why it's decreasing. And again, you're looking at the x values there. It's -3 to 0. Would you like to do another example like this before we move on?
Yes.
Okay. Let me search for one before I make one up. See if we can find one real quick from a graph. Yeah, so the first one I found is much more straightforward than this one. Just check one more here. This would be good for us to do. Yeah, if I found one here, this one's probably okay. Okay, so we're gonna answer the same set of questions for this graph right here. And hopefully that's big enough to see.
Yeah, I can see it.
Okay, so let's first talk about the domain of this one. So the domain is, what's the leftmost x value that you see?
So -5.
-5. Now, does it include -5? Is that an open or closed circle there?
It's an open circle.
So it does not include it. And then how far to the right does it go?
5.
5. Now in your class, you might have some arrows going. So those might go to infinities, but for this one, it does not. Range. So, okay. So another word for domain is like left to right.
Okay.
And range is like bottom to top. So what's the smallest y value that you see in this graph?
I see -2.
-2. Now, does it include -2?
No.
It doesn't there, but it does here.
Oh, okay.
So since it does at one place, you can include that.
Okay.
So since it's filled in here and here, you can include the -2. And then how far up does it go? What's the largest y value?
2.
+2. And you include that because it's a solid line there.
Okay.
Then we talked about increasing, decreasing, and constant. Let's do the constant first. And that's the horizontal line. Where is this horizontal? And you can see there's 2 places. Let me do it in red here. It's here and here.
So the first one looks like it starts at -3 and goes to 0. And then the second one is from 2 to 3.
You got it. Yeah. All right. So now increasing means it's going up and to the right. So that looks like here.
Uh-huh.
And that looks like there. And we need the x values again of that.
So -5 and -3 is the
Good.
first one. And then the second one, 3 and 4.
Perfect. And then the last one there is decreasing. Decreasing goes down and to the right, down and to the right, down and to the right. And we can say 0 to 2, comma 4, comma 5 for that. I know this was different. It wasn't the same as this example up here. This one had some breaks in it. You clearly understood this. Maybe just review the video and see if this is clear again.
Okay.
We look at it because there is a lot to get through here to be able to get through everything. 6, I'm looking at 6 from your work. There is kind of a major, it works-ish, but there's kind of a major thing here. So let me just start 6 over from the beginning. You got kind of half of it right. And that's good because especially if you haven't seen this in a while.
Oh yeah, I don't think I finished that one. I just started it, but.
So when you solve absolute value equations like this, it's kind of like other things. You're trying to isolate the absolute value term. So that's this right here, which means you have to undo the 3. The 3 is multiplying. So you undo the 3 by dividing both sides by 3. So now the absolute value term is isolated. The next thing here is there's 2 properties of absolute value. There's one for less than and one for greater than. We'll do the less than first. Is you're going to be given something, and I'll write it this way. You're going to be giving something less than or equal to a number. And you always write it this way: number, the function without the absolute values, and then the negative of that number over here. So the number comes down, the number comes down, and then this comes straight down. So you've got 3, 4x minus 1, and then -3 here on the left. And this is called a compound inequality. Do you remember how to solve these?
So you just solve it like an equation. So you would add the 1 to both sides.
Yes, there's like multiple sides here, which is a little bit different. Yeah. Okay, and then do you remember what to do from here?
And then just divide the 4 so that x is x. So then it would be
-1/2 less than or equal to x less than or equal to 1. And that's like, it's like, how do I say it? Like they're just asking you to solve. This is correct. Sometimes they want you to rewrite it, but this is correct.
Okay.
All right, so now 7 and 8, we should do 7 next, I guess.
Okay.
Okay, so kind of like the first problem, your first task here is to isolate the absolute value term,
Mhm.
which is this one right, right there. So you could treat this like big X if you wanted, and you have to undo the 1 and undo the 1/4.
Mhm.
So you subtract 1, multiply by 4. Multiply both sides by 4 to clear it. And you're just multiplying this. So it's 2x minus 6 equals 4. And now you have a property again. You have the absolute value f of x equals a number. There are some exceptions that I'm not covering. They do apply to the previous one as well. Do you think this exam is going to be a lot like this practice one?
I think she did make this one this time, so it might
Might be similar. Okay.
The last one she made was completely different from the test.
Yeah, that's tough. So here, this produces two things. It produces f of x equals the number, meaning like whatever's inside the absolute value, just said equals. So it'd be like 2x minus 6 equals 4. That's one fork. The other fork is f of x equals negative of that number. So 2x minus 6 equals negative 4. And from here, you can solve those. So I'd like you to do that for me. Let me know what you get for a final answer whenever you get down there.
All right, so I got x equals 5 and x equals 1.
And I'm just checking that. Yeah, x equals 5, x equals 1. Good. Okay. These are kind of more mechanical. They're often a little more straightforward to remember how to solve. All right, so we'll go to 8. 8 is coming up here. All right, so question 8, you can kind of do the same thing you did in the previous problem where you isolate the absolute value. Sorry, let me just get this where it's centered. So you can like add 6 to both sides. -3, absolute value x minus 1 equals 9. You're trying to isolate this x minus 1, so you divide by -3, divide by -3. So absolute value x minus 1 equals -3. And this is a problem. Now you might say, Matthew, we just did something like this one. We have the absolute value of x equals a number, and that's true. So we have to remember that the absolute value function, it starts out like this. It's a v. And all this other stuff over here, like all it basically does is like shift it left or right. So the one that we're looking at here, it's shifted over here to the right like this. And at its core, when you're setting something equal, we're looking at the intersection of the two graphs. So -3 is this line down here. So will this v ever hit that line down below it?
No.
No. So this has no solution, but you can very easily work this out and act like you found a solution and feel really good about it. And unfortunately, it would be just completely wrong. So the number over here, the thing that I just mentioned, this number, it has to be 0 or positive. But it's when you isolate this that you're looking at it. Because you might say, well, Matthew, this is +3. That's true, but it's not positive when you get down to just the absolute value by itself. Is that
Yeah, that makes sense.
Okay. It's a very important thing. That's a distinction between, this and other stuff.
Mhm.
Okay, we're
Whenever
gonna,
it's negative, it's always going to be like no solution when it comes down to just the absolute value in the negative number.
if it equals a negative number, there is no solution. Yes.
Okay.
Okay, we're gonna come back to 9 and 10, but 11 fits better with the kind of the path we've just taken. So just to go back a little bit, 6 is a is an absolute value less than or equal to 7 and 8. They were absolute values equal to, and 11 here is an absolute value greater than. And these are like the three types that you have to know really well. And then we'll do 9 and 10. But I want to just get this clear first. So you still isolate the absolute value term. This one here. So you're going to undo by subtracting 6. So you have 3 absolute value 1/2 x plus 2 greater than 9. And then you divide by 3, 1/2 x plus 2 greater than 3. So this is another definition. Okay, so your definition is I've got the absolute value of something greater than a number. So what do I do? Well, there's forks here. You have f of x greater than the number, or f of x less than negative of that number. So for example, here you would write 1/2 x plus 2 greater than 3, or 1/2 x plus 2 less than negative 3. And then you solve each of these individually. So I'd like you to do that. Let me know if you have any questions about solving it. I'll confirm your answer if you need me to, but did you get something like that? I'm sorry, this one's not right. This is -5.
The first one I got x is greater than 2, and then the second one is x is less than -10.
Good. Great. So you understand that. This is really key. You have to know the 3 types, and you have to know the definition for each type. So the first one becomes a compound inequality between. The second one you fork, and then the third one you also fork, and you just have to have those down in preparation for your exam or quiz or whatever you got coming up. All right, so moving to 9, what you have done is correct for half the problem.
Okay.
So the work that you've done, it looks great, except you've only done half the problem, so you get 5 out of 10 points, which is never good. You say, well, I thought I did it right, and so this is like the case up here where if it's an equal sign, you essentially use this. Okay, the issue though is you have 2 functions, so it's a little bit odd. So let me try and show you here. If you have the absolute value f of x equals the absolute value g of x, like you did the first fork, is you just set them equal. The second fork is you have to negate one of them, and most of the time people negate the one on the right. Now you negate the whole thing. So you already did this one. I'm not going to redo it. I'm just going to write it down here. For this other one though, you negate everything. So it's -x minus 6. There's implied parentheses right there. So you don't want to just negate the first one. You'll get the incorrect answer. So this is -x plus 6. Add x to both sides. Subtract 2, you get 4x equals 4, and you get x equals 1 again. You already got that though. Oh, 2x. Oh no, you did this right. I'm so sorry. I didn't follow your work. I apologize. You have this down perfect. And I'm used to seeing this up here, but this is correct and this is correct. Well done on that. Okay.
And then,
Yeah, so number 10 is also correct.
okay.
It's an exception, like, because these are actually the same thing. And I don't know if your instructor expects you to pick that up, but it's the same thing. Okay, great. So we've got some time left here to keep going. Do you want us to move to 2.6? Do you want us to do more questions like some of the earlier problems on the practice test? What would you prefer?
Oh, so for 2.6, we just started doing problems like 61 and 63. I think we're probably gonna go over that more on Thursday, but the last 5 minutes of class, she kind of started incorporating some of that. So I feel like I should just try and do that to be prepared for Thursday's class.
I think that's a great idea. So let me snip those in for 61, and we'll see if it's clear. All right, and then part A. Part A is to do f bubble g of x. Let me snip that in. Great. So I never found this to be very useful. That's on the left. You want to immediately convert it to something like this, in my opinion. I feel like this is more clear. This is g of x, the inside, and then you replace this wherever you see an x and f of x, because f of x is the outside function. And we're going to do the other direction, but you have to be clear that you take the inside function and use it in the outside function. So this becomes square root 1 minus x squared. And this equals 1 minus x. Now it looks like you're doing domain.
Yes.
Okay, so this is where it's different than, like, you don't look at the end result. You look at the first two functions. You look at f of x, which is x squared, and you say, what is its domain? What is the domain of that original function? And it's a parabola. You know, it opens up, no issues. It's all real numbers. We're very happy. G of x is the square root of 1 minus x. Do you remember how to find the domain of a square root function?
It's been a little bit, so.
Okay, so you set the inside part greater than or equal to 0. So 1 minus x greater than or equal to 0, and then you solve for x. You have to be careful here, though. It's better to add x to both sides, because then you get 1 greater than or equal to x, and then you just flip it, x is less than or equal to 1.
Okay.
If you subtract 1, and then you have to divide by negative, you have to remember, oh yeah, I got to flip that inequality. So x less than 1 means you can go from minus infinity to 1. So to find the domain of the composition function, you have to take into account the original domains. Like, while x squared is good everywhere, square root of 1 minus x is not good everywhere. So you look for the more limiting of the two. This one is more limiting because the first one goes forever. This one only includes everything up to 1. Actually, that's a bracket there. I don't think this is super clear, but maybe the examples will be reasonable and you won't have to have anything odd for them. So if that wasn't clear, I can give you a few more words to that. Maybe try it another way to explain it.
Okay. Yeah, probably, just because.
Okay. So we said f of g of x, which means you're starting with g of x. And the domain of g of x is x less than or equal to 1. That means you can only use numbers that are less than 1, less than or equal to 1. And you take the output, so like you start with g of x, and you take the output of that, and you put it into f of x. So like, if this represented all the numbers in the world, you're not starting with that. You're starting with like that many numbers and going here. So because you're limited on what you start with, you're limited on where you go next. So the output here, which is the bubble, the output is this f of g of x. Even though it's nice, it was just 1 minus x. The problem is that you can't give it everything you want to start with. You can't start with all the numbers here. So when you get to here, you can't use all the numbers there. I wish I had a better kind of common sense example. Okay, have you ever been to Costco?
Yes.
Okay, so Costco has like all the stuff you could ever want in the world, but you have a shopping cart. Mm-hmm. And you can't put everything in your shopping cart, can you?
No.
No. So this, when you say x is less than or equal to 1, that's like saying, like, I got to choose something less than 1. I can't put everything in my shopping cart. Mm-hmm. So when you go out the door to your car, this is your cart, and you go out the door to your car, like your car, you can't get everything in there. You can only take this stuff and move it in there. Yeah. And that's what I meant by limiting. Like your cart's only so big, so you can't put everything in it. Okay, so now I'm going to grab 61 again, and we're going to do part B. And part B is just going the other way. It's G bubble f of x. Let me snip that in. G bubble f of x. And what that means is you start with f of x, and you take f of x and you put it in wherever you see an x. All right, so that means you start with f of x and you put it in. So this becomes square root 1 minus x squared. And you're done here. Like you might think, oh, can I simplify? And you cannot. There's nothing more to do here. So that's this. So let's go back to this idea of like, what's the domain of f of x? How much are there any limitations on f of x? It's x squared. You can put any number you want into x squared. You agree with that?
Yeah.
Okay, but when you get here, like let's just say x is 4, and you square it. Well, 1 minus 16, that's no good because that's a negative number. It's the square root of a negative number. So even though you can put whatever you want here, when you get to g of f of x, you have to then say, oh, well, what's the domain of this new thing that I've got? Because I'm not limited here, but I am here. I can only take the square root of a positive number. Mm-hmm. So that means you have to set 1 minus x squared greater than or equal to 0. Because you set the inside part greater than or equal to 0. Now this kind of also leads off to a little bit of an aside. Do you remember difference of squares factoring?
Oh yeah, I remember.
Okay, so this is a difference of squares. This is 1 minus x, 1 plus x. And it ends up being that when you, we probably shouldn't go into too much more detail on this, but when you graph this function 1 minus x squared, it looks something like this. Mm-hmm. So where is it above 0? Well, it's above 0 from here to here, from -1 to 1. It's okay if this wasn't clear because you'll see it again. I'm gonna go run through 63. I think it'll help because there's some of the similar ideas here. So part A is f bubble g of x, which is really f of g of x. So this much should be clear. You're taking this and you're putting it in for x. So that's 1 over 5x plus 1. That much should be clear. Now, when we talk about the domain, we're starting with g of x. Is there any limitations on g of x? And there's always two things you're looking for in math. There's division by 0 and the square root of a negative number. We don't have either of those here. So g of x is great. All real numbers, super happy. Okay. Now we go to f of x. What's the problem here with f of x? What is one value that causes you to divide by 0? If x is
0 or no,
what makes the bottom 0?
-1.
-1. So everything but -1 is bad there. So see how we're kind of limited? Like, even though you can put whatever you want into g of x, you can't put -1 in for x.
Yeah.
So let's just say x was 1/5. G of x becomes 1. I'm sorry, -1/5. G of x becomes -1. That's bad. Okay. So now let's go to f of g of x, which is this thing right here. You're concerned when this equals 0. So you set the bottom 5x plus 1 equal to 0. And when you solve for x, you get x equals -1/5. And this is an excluded point. And that's what we were showing right here, is like that it's bad, basically. So the domain is all the numbers except for that one. All right, how are you doing on that side of the virtual window?
I think 63 definitely makes more sense than 61. I think I just have problems with like the square root.
What's not fair here is usually they start out with f of x is x squared and g of x is like 3x plus 2. And these always are nice in the beginning. That's why I was drawing that staircase. It seems like your instructor is up here at level 4 and you're used to these problems down here at level 1 and 2. And we got to get you up that learning staircase. Okay. So that does end our lesson for today. I'm going to send you well, I guess I got your mom's email, but I'm going to send the notes and the screen recording to her.
Okay. Yeah, she'll just forward them to me.
Excellent. So thank you very much. And I'll see you next time.
All right. Thank you.
You're welcome. Bye now.